Welcome to this deep dive. Today, we're jumping into something pretty crucial if you're prepping for those senior software engineer interviews.
Oh yeah, what's on the menu?
System design territory. Specifically, tackling breaking changes in microservice APIs. It comes up all the time.
Ah, yes. The classic headache. How do you evolve your service without, breaking everything that depends on it? It's a real balancing act.
Exactly. And it's not just about the code, right? It's about strategy, trade-offs, the kind of thinking expected at a senior level.
Absolutely. It's about understanding the different ways to handle it, the pros and cons, not just knowing one way.
Okay, so let's break it down. When we say breaking change, what are we actually talking about? It's not just adding a new field, is it?
No, not usually. I mean, if it's optional, maybe not. But a breaking change is something that stops existing clients from working properly if they haven't updated.
Like removing a field they expect.
Exactly. Or changing a data type, renaming something, maybe restructuring the whole response, anything that violates the old contract.
Right. And you want to make changes, improve things, add features, but you can't just ignore the consumers.
That's the core tension. Innovation versus stability. How do you update without forcing everyone to update at the exact same time or causing chaos?
So that's the million-dollar question, especially in an interview context. How do you manage it without that painful synchronized deployment?
Well, there are a few main strategies people talk about. The first one, maybe the most obvious initial thought, is lockstep deployment.
Lockstep. Okay, so that's basically everyone updates together, service and all consumers, bang, same time.
Pretty much. You roll out the new service version, and simultaneously, all the apps using it roll out their updated versions that work with the new API.
Sounds clean, in theory.
In theory. But think about microservices. What's the big promise?
Independent deployment, right? Teams can release their own stuff on their own schedule.
Exactly. And Lockstep just throws that right out the window. If service A needs service B and C to update at the same time it does,
You're back to a distributed monolith. All the pain, none of the gain. Coordination nightmares. Release bottlenecks.
precisely. It couples everything back together. Now, are there any cases for it? Maybe. Like maybe a tiny team owns the service and it's only a couple of consumers and it's a very controlled one-off internal change? Perhaps. But you got to be super careful it doesn't become the default. It's generally an anti-pattern.
Okay, so rule number one for the interview. Generally avoid recommending lockstep. Got it.
Yeah.
What's option two then, if we want independence?
Option 2 is running different versions of the service itself, side by side, coexisting versions.
Okay, so you'd have like Service V1 running and also Service V2 running in production at the same time.
Yep. Old clients get routed to V1. New or updated clients hit V2.
That keeps the old clients happy, they don't break.
Yeah.
Seems reasonable, but sounds kind of complicated too.
It can be. Think about it. Now you have two separate things to manage, to deploy, to monitor.
And bugs. What if you find a security bug?
Good point. You likely have to fix it in both code bases. Patch V1, patch V2. That probably means maintaining separate branches, which can drift apart over time. It gets messy.
Yeah, I can see that. And how does the traffic know where to go? Who sends the V1 request to the V1 service?
Right. You need some smart routing, an API gateway, maybe a load balancer, sometimes even logic built into the clients, though that's less ideal. That routing logic itself adds complexity.
Okay. And what about data? If V1 and V2 use the same database?
Oof, yeah, that's another big one. If V2 changes the data schema, how does V1 cope? Or what if V1 writes data that V2 doesn't understand? You risk data corruption or weird behavior if you're not incredibly careful with how they share state.
So running two full versions sounds like maybe a short-term fix, like for a canary release or something.
Exactly. It's often used for things like canary testing rollout V2 to 5% of traffic alongside V1. But for a long migration period where consumers might take months to update, the overhead of running separate full versions gets pretty high.
So it's an option, but maybe not the preferred one for longer transitions.
Often, yeah. Which leads us nicely into the third main strategy,
Which is?
emulating the old interface within the new service. So you only deploy one service version, the new one.
Okay. But how does that help the old clients if the new service has breaking changes?
Because the new service is built to be clever. It exposes both the new V2 endpoint, say, and it still understands and responds correctly to requests coming into the old V1 endpoint.
So V2 knows how to pretend to be V1 if needed.
Exactly. It emulates the old contract. This means you can deploy your shiny new service independently. Existing consumers talking to the V1 endpoint don't even notice. They keep working.
And that gives them time to upgrade to the V2 endpoint at their own pace.
Precisely. It decouples the service deployment from the consumer upgrades. It fits that expand and contract idea really well.
Expand and contract.
Yeah, you expand by adding the new V2 capability while keeping V1 support. Then, over time, as clients migrate, you monitor usage, and eventually you contract by removing the V1 endpoint and the emulation code.
That sounds much more manageable long-term. You don't have two code bases, just extra logic in the one.
Right. You might have, say, a V1 customer endpoint and a V2 customer endpoint served by the same service instance.
How does that emulation work internally? Does it just, like, fetch the new data and then strip out the new fields for V1 callers?
That's one way. Or sometimes, especially if you end up supporting V1, V2, V3, you might see internal transformations. A V1 request comes in, the code transforms it into a V2 request format, calls the core V2 logic, maybe transforms that into a V3 format to call the absolute latest core logic, gets the V3 response, transforms it back to V2, then transforms that back to the V1 format for the original caller.
Whoa, okay. Chain transformations. Sounds potentially complex, but keeps the core logic cleaner, maybe. Focused on the latest version.
It can, yeah. It centralizes the core business logic around the newest contract and treats older versions as translation layers. It makes eventually removing V1 easier, then V2, and so on.
Makes sense. How do clients actually specify which version they want? You mentioned V1 and V2 in the path.
That's super common for REST APIs. Version in the URI path. Easy to see, easy for routing infrastructure like gateways.
Downsides.
Some argue it couples the client to the URI structure too much. The alternative is often using HTTP headers, like an accept version header or a custom one.
Cleaner URIs then, maybe.
Yeah, the URI stays customer, but the header says V1 or V2. But headers can be less obvious for developers browsing the API. Trade-offs, you know.
Always trade-offs.
Okay.
What about non-HTTP stuff, like gRPC or protobufs?
Similar ideas apply. With protobufs, you often use namespaces. You might define a customer.v1 service and messages, and later a customer.v2 set. But managing incompatible type changes between versions, like changing a field from a string to an integer, gets tricky with serialization and deserialization across versions. You need careful planning there, too.
Okay, so we have Lockstep avoid, parallel versions, tricky, and emulation, often preferred. But it feels like there's more to it than just the tech choice.
Oh, absolutely. A huge part of it is let's call it the social contract.
Social contract.
Yeah.
Between the service team and the consumer teams.
Exactly. You have to communicate proactively. How are breaking changes even proposed? How do teams collaborate on the new design? Crucially, who's responsible for updating the consumers?
Yeah.
Is it the service team, the consumer teams? Shared effort.
And timelines.
Yeah.
How long do consumers realistically have before V1 disappears?
Yes. All that needs to be agreed upon upfront, or at least have a clear process. Otherwise, you just drop a break and change on people, and, well, nobody likes that. It really pushes towards that consumer-first mindset.
Right. Your service exists to serve others. Breaking them isn't serving them.
Precisely. And sometimes consumers can't upgrade easily. Think legacy systems or maybe IoT devices already shipped out in the field.
Ooh, yeah. You can't just push an update to 1 million smart fridges easily.
Right. So then the decision to keep supporting V1 becomes a business decision, a financial one. What's the cost of maintaining V1 versus the value those consumers bring?
Man, okay. That adds another layer. So assuming you do want to retire V1 eventually, how do you know when it's safe? How do you track who's still using it?
Monitoring and tracking are absolutely key. You need logs, metrics. For every request, you should know which version was called, V1 or V2, and who called it. Maybe based on an API key or a client identifier header.
So you can actually see, okay, Tmax is still hitting V1 1,000 times a day.
Exactly. Then you can go talk to teammates specifically. Hey, we see you're still on V1. The deadline is approaching. What's blocking you? How can we help?
Makes sense. Targeted communication based on data.
Yeah.
What if? What if they just don't migrate? You've warned them, helped them, the deadline passes. Can you just keep V1 running forever?
You could, but you probably don't want to. It's technical debt. It complicates your service. So eventually, after all the warnings and support, you might need more assertive measures.
Assertive? Like what? Sending tough emails?
Well, that first. But ultimately, one option is you set a final date, communicate it widely, and then you turn off the V1 endpoint.
Just switch it off.
Switch it off. It's drastic. It will break anyone still using it. That's why the tracking and communication beforehand are so critical to minimize the blast radius.
Wow. Okay. Any less aggressive options?
Some people talk about introducing artificial slowdowns, like adding a Sleep 500 call to the V1 endpoint handler.
Seriously. To make it painfully slow so people have to move.
Yeah. It's controversial, ethically dubious, maybe, but the idea is to strongly incentivize migration without completely breaking things immediately. It's definitely a last resort kind of tactic.
Huh. Okay, extreme measures aside, the goal is planned retirement based on usage data and clear communication.
That's the ideal, yes. So you have these main technical paths, lockstep, rarely, parallel versions, sometimes short-term, emulation, often good. But weaving through all of that is communication, tracking, and that consumer-first approach.
Okay, let's try to wrap this up. So, three main technical options we've dug into. Lockstep generally bad for microservices. Coexisting service versions can work, especially short-term like canaries, but has overhead. And emulating old endpoints in the new service, often the most flexible, lets consumers migrate at their own pace.
That sums up the technical strategies pretty well. And underpinning all of it, the big takeaway, especially for someone prepping for that senior interview,
Yeah.
is that managing these changes successfully isn't just about picking the right pattern. It's about the planning, the collaboration, the communication around the pattern. It's demonstrating you understand the whole life cycle and the impact on the wider system.
That's system thinking, seeing the bigger picture.
Exactly. Balancing the need to evolve with the need for stability.
Okay, great stuff. So, for everyone listening, especially if you're gearing up for interviews, here's something to chew on. Thinking about these strategies, lockstep, coexistence, emulation, which one, or maybe which combination or thought process do you think really shows that senior level maturity? Which approach best demonstrates a deep understanding of distributed systems, their trade-offs, and the human elements involved? And importantly, be ready to explain why you think that. Consider the communication, the risks, the long-term maintenance. Food for thought. Thanks for diving deep with us today.